This is Mr. Castillo, and in this video, we are going to review Units 3, Grade 5, Unit 3, Multiplying and Dividing Fractions. Okay, so here we have a diagram, and it's asking us to write an expression to represent the area of just one small shaded piece. So, one small shaded piece will be, for example, one of these small shaded pieces right here. Okay, so it's asking us an expression to represent the area. So when you think of area, think length times width. So let's look at the length over here. This will be the length right here. And this will be the width. It really doesn't matter what you think is the length or the width. You multiply one side by the other side. Let's make it a different color. Okay, so I'm going to calculate how much do I have right here on this side. So this is going to be, I'm going to count. So I have one out of, let me see, 1, 2, 3, 4, 5, 6. So over here on this side, I have 1, 6. And over here on the green side, I have 1 out of, let me see, 1 out of 1, 2, 3, 4, 5. I have 1 out of 5. So I have 1/5 here. Why do I have 1/5 and not 1/8? Because the whole ends right here. And our fractional and our denominator is going to be based on the whole. So one whole is based on 5/5 over here. 1, 2, 3, 4, 5. So here we have just one of those fifths over here. So the expression for the area of this little square here is going to be length times width. So that's going to be 1/6 times the 1/5 over here. That is going to be the expression. Okay. So now the next question is going to be, what is the area of the shaded region? So now we're looking for the area of the whole shaded region. Let's just erase this part right here so we don't get confused. Okay. So right now I'm looking for the area of the shaded region. So all of this right here is the shaded region. All of this. From here to here. All of this is the shaded region. So again, when you think of area of a square, for a rectangle, you think length times width. You're multiplying the side lengths. Okay, so this is going to be, right here, this is going to be this side is going to be my length right here. And this side right here is going to be my width. Okay, so we're going to multiply length. So area equals length. I'll put this a different color. Area equals length times width. So this will be my width over here. Let's make it green this time. All right, so what is my length? Well, I'm going to go over here. I know that my denominator is going to be the whole from here to here. It's going to be my denominator. So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 pieces. Okay, so 8 pieces out of what? Well, we have to calculate only from the whole. So 1, 2, 3, 4, 5. Only from here to here. That's my denominator. I have 8 fifths over here. Because this is a fifth. That's another fifth. That's another fifth. That's another fifth. That's 5 fifths, which makes 1 whole. And all of these other ones are above a whole. So that's why it's 8 fifths. This is going to be times my width, which is going to be 1, 2, 3, 4, 5. 5 out of 6 in total. So 5, 6. Okay, so let's calculate the area of the shaded region. So we're going to just multiply across, just like we multiply fractions, like that. Just multiply the numerators and the denominators. So we know that 8 times 5 is 40. So this equals to 40 over 5 times 6, which we know is 30. Okay, but this fraction here is an improper fraction, so we cannot leave it like that. Okay, but before we turn it into a mixed number, let's simplify it first. I know that this is just 4/3. 40 over 30 is equivalent, is the same as 4/3. And we can do that by dividing it by 10. So it's the same thing as 4/3. So 4/3, we're going to convert that into a mixed number. So 4/3, I'm going to convert it like this. I'm going to just decompose this. I'm going to decompose it as like this, as 3/3, plus an additional third to make it 4. So I know this is 1 whole over here. Well, I'm sorry, I made a mistake. This is a third. 3/3 plus another third. Okay, so 3/3, this is 1 whole plus another third. So that's 1 and 1/3 square units. That is our area. 1 and 1/3 square units. So we're going to put just units square here. All right, let's go into our next question. All right, write a division and multiplication expression that represents the shaded region. Okay, so for that we have to interpret this diagram. So let's look at this diagram here. And I noticed that this diagram represents 1 whole. And this whole is divided into parts. So we have a fraction here. So let me see what's going to be my fraction. Let me see my parts. I have 1, 2, 3, 4, 5. So here I'm working with fifths. And I notice that this part right here is 1/5 right here. So we notice that we have 1/5 that is being cut up, is being divided. It's being divided right here in 2 parts. So 1/5 divided by 2 is our division expression. Okay, so to write our multiplication expression, we're just going to to convert this to multiplication by using the strategy of keep, change, flip. So our multiplication expression is going to be 1/5. Oh, this should be red. 1/5 times the flipping of these two wholes, which is really 2/1, is going to be 1/2. So here we have times 1/2. This is our multiplication expression. And what this means is, like, if you will calculate this, that's going to be 110, right? So that's going to be 110. And it's true because if you will break this up, if you break up all of these fibs in two, you're going to end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So that's how you end up with 110. And precisely this shaded piece right here represents 110. So that's why this multiplication expression is valid. And so is this division expression. Let's look at the next one. Okay, so again, we're going to write a division and multiplication expression to represent the shaded region. Okay, so I notice here that this is one whole from here to here. Okay, so that means this is a fraction. We are dividing a fraction. Okay, so what is the fraction? I see this one part, another part, and another part. So we're working with thirds. Okay, so let's identify the third right here. This is the third. It's 1/3. This red part right here is 1 out of 3. So we have 1/3. And this 1/3 is being divided. It's being divided into how many parts? It's being divided into 1, 2, 3, 4. It's being divided into 4 parts. So our division expression is going to be 1/3 divided by 4. Okay, so what is going to be our multiplication expression? Well, simple. We're going to use our strategy of keep, change, flip, or you can say keep, switch, flip. It's the same thing. We're going to keep the 1/3. We're going to change this to multiplication, and we're going to flip this 4, which is really 4/1, right? And if we flip 4/1, it's going to be 1 out of 4. Okay, so this is going to be our multiplication expression for this. All right, let's continue. All right, so it says find the value of each product. And we're going to simplify whenever it is possible. Okay, I think all right. I think I skipped the page. Oh, there you go. Right here. Find the value of each expression. Okay, so here we have some division expressions, and we're going to remember the rule that we learned about how to divide fractions, either a whole number by a unit fraction or a unit fraction by a whole number. So this is going to be the rule that we're going to follow. We're going to follow this rule. So the first part we're going to keep. Okay, keep, change, flip. That's going to be the rule that we're going to follow. Keep the first part, change to multiplication, right? And then you're going to flip. That's called the reciprocal. So let's do the first one. So the 4 we're going to keep, okay? The 4 we're going to keep. If you want to make your life easier, you can just put a 1 over underneath here. Just put a 1 underneath. Just that we turn this to a fraction, so it's easier to see. So we're going to keep the 4 ones here. 4 ones. And then we're going to change this to multiplication. And the 1/3, we're going to flip it to 3 over 1. So the answer to this is going to be 12 over 1, which is simply 12. Okay? Let's try the next one. All right. Let's try this one now. 1/3 divided by 4. So again, we keep the 1/3. We switch this to multiplication. And this, which is really 4 over 1, we're going to flip it. And that's going to be 1 over 4. So now this time the answer is going to be 1 over 12. Let's look at this one now. So we have 1 out of 20 divided by 4. So that means that you keep the 1/20th. You change this to multiplication. And this, which is really 4 over 1, 4 ones, same as 4 wholes, that is, we're going to flip that. That's the reciprocal. Okay? So now we're going to do 1 times 1. And we're going to do 20 times 4, which we already know that 2 times 4 is 8. So 20 times 4 has to be 80. All right, so that's our answer. Oh, did we circle this answer? Okay. So now we have 4 divided by 120. So again, we are going to, we're going to keep the 4, which is really 4 over 1. I'm going to keep that. Then this division sign, this division symbol, we're going to change it to multiplication. And this fraction right here, we're going to flip that, okay? So this 120 is going to become, 1 out of 20 is going to become 20 over 1. So now this is going to be 80. All right. So let's try the next problem. We have here that Ashley wants to run 5 miles. The track is 1/2 mile long. How many times will Ashley have to run around the track? So she wants to run 5 miles. But the track is only 1/2 mile long. How many times will Ashley have to run around the track? Okay, so basically, just because it says how many times doesn't mean multiplication here. In this case, actually, it's asking how many times will Ashley have to run around the track. In other words, how many 1/2s are in, how many 1/2s are in 5? How many 1/2 miles are in 5 miles? So basically, this is saying division here, because you're asking how many times this number fits into this number. How many times will Ashley have to run around the track? So how many 1/2s to get to 5? So that means you're doing 5 divided by 1/2. Okay, so, and of course, using our rule of keep, change to multiplication, and flipping this, you're going to get 5 times 2 over 1, which is 2, and you get 10. So, And it's good to write out answer as a complete sentence to make sure that it made sense. So you're gonna say, Ashley has to run 10 times around the track. So you will write that here. Ashley has to run 10 times around the track to run 5 miles. And that makes sense. Okay. And you can even test it out, because if you do um, 1/2 10 times, so, oops, I meant 1/2 here. 1/2 times 10, you're going to get 10 halves, right? And 10 halves is nothing other than 5 miles. So you can test out your answer here, or you can draw your diagram, okay, and you can draw your 5 holes here. Let me see if I can accurately draw this. Try my best. 1, 2, 3, 4, 5. There you go. So this represents 5 miles. Okay, so this is 5 miles. 5 miles. So now if this is 5 miles from here to here, that means that each one of these right here, from here to here, for example, from here to here, is 1 mile, right? This is 1 mile. 1 mile. From here to here, and from here to here is another mile. Okay, so and that means that each mile you divide it in half. Okay, so you cut it in half. You cut each mile in half. Right, so you have a bunch of halves here. A half here, 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 etc., etc. And how many? Each one half represents a time that she goes around the track, right? So 1 time, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So that's why she ran around the track 10 times. Okay. All right, let's look at the next problem here. Find the value of each product. Simplify whenever possible. Okay, so the rule for multiplying fractions is always going to be the same. You just multiply across, especially like this type of regular fractions. Now, when we get to do a whole number by a mixed number, well, I'm going to show you. And a mixed number by a mixed number, well, you have to convert them to improper fractions. But let's start with the first one here. So here you just multiply across. You do 3 times 4 and 9 times 6. So you get 3 times 4. That means you get 12 out of 54. Okay, so now here it says simplify whenever possible. So let's simplify this. So we can simplify this by using division, by dividing it, by finding out which number goes into each. So we can use 6. We should use the highest number possible, so we don't have to do it again and again, because of course we can use 2, but then we have to do it again and again and again. So what is 12 divided by 6? Well, I know that 2 times 6 is 12, so that's going to be 2. What is 54 divided by 6? Well, I know that 6 times 9 is 54, so that's going to be 9. So the answer is 2, 9. So for this one now, the rule is to use the distributive property. So first you're going to do 4 times 5 times 4 times 7/8. So you're going to go ahead and do 4 times 5. There is the 4 times 5 right here. Plus the 4 times 7/8. 4 times 7/8. So let's put parentheses. And let's keep going. So what is 4 times 5? That's 20. Plus the 4 times 7/8. Well, 4 times 7/8, well, we know that 4 times 7 is going to be 28. We keep our denominator. The reason this happens is because we put 4/1 here, and we just do 4 times 7, and 8 times 1, that's still 8. So it's 28/8. So now we have to find out what is 20 plus 28/8. Oh, now to figure that out, we have to convert this back to a mixed number. Okay, so to do that, there's various ways to do it. One of my favorite ways is to just decompose it. So this 28/8, let's decompose it. Okay, 28/8. Okay, so that's gonna be, I'm gonna find a multiple of 8, so that's gonna be 24/8. 24/8 plus an additional 4/8. Okay, so I know that 24/8 is 3, because 24 divided by 8 is 3, plus the additional 4/8. So this is going to be equal to 20 plus the 3, this 3 right here, plus the 4/8. Okay, so now we're going to combine our terms here. So we're going to combine, this is 23. So 23 equals 23 plus 4/8, which is the same as 23 and 4/8. Okay, so that's 23 and 4/8. And actually, we can simplify this further, because this is 23 and a half, basically. Okay, so you can say 23 and a half or 23 and 4/8. All right, but let's go to the next one. So the next one, when you have a mixed number times a mixed number, you have to convert both mixed numbers into an improper fraction. Because if you use the distributive property here as possible, it makes it much more complicated. This is the easiest way to multiply mixed numbers, is to turn them both into improper fractions so that we can just multiply across. So let's go ahead and do that. But how do we turn that into an improper fraction? Well, we're going to use our rule of, you're going to go from here to here like that. And you're going to add, you're going to multiply the 3 times 6. So first you're going to multiply 3 times 6, and then you're going to add the additional 2/3. Okay? Because that's what the 6 wholes means here. You have 6 wholes of 3/3. So it's the same as saying you have 3 times 6 plus the additional 2/3. So the first one, we're going to do the 3 times 6, right? So that's going to be 18 plus 2 more. It's going to be 20. So that's going to be 20 thirds. We keep our denominator. So 20 thirds. And here we have 2 and 2/5. Again, we're going to do 5 times 2, 5 times 2, 5 times 2 plus 2. So 5 times 2 is 10 plus 2 more is 12. So we have 12/5. Okay. Again, I mean, you can watch other videos to see how to convert this. Okay. I don't want go too deep into it, but there are other videos on my channel about it. So let's just multiply across here. 20 times 12. Okay, well, we know that 20 times 12 is going to be 240, because we already know that 2 times 12 is 24. So 20 times 12 has to be 240. And here we're going to do 3 times 5. Okay, so from here now, we have to divide. 3 times 5 is 15, yeah. We have to divide 240 divided by 15. Because here, doing it this way right here, yeah, it's gonna take us too long. Okay, to extract 15 out of 15 plus 15 out of 15, etc. It's just gonna take us too long. So, let's go ahead and just do the division. Okay, and to help us do the division, we're gonna write the multiples of 15 over here to help us out. Okay, so, and that's what you should definitely do too. So you can do 15, 30. So we just keep counting by 15 here. 45, 60, 75, 90. Okay, so you're just adding by 10 plus 5, 10 plus 5, and then just keep counting by 15. All right, let's just leave it right there, because it's probably going to be about 90. Okay, so let's go ahead and do, this is a part. So we're going to do 240 divided by 15. So we have to ask ourselves, how many times does 15 go into 24? Well, I'm not going to ask how many times 15 goes into 2. Well, we'll do another video about division. But right now, let's just do this rather quickly. Okay, so 15 goes into 24 one time. Okay, so we do 15 times 1. That gives us 15. Okay. We're not subtract it. Just correspond to here. Okay, that's how we got the 15. And now we're going to subtract 24 minus 15, which is going to be 9. You borrow, then you 14 minus 5, 9. Okay, now this 0, you're going to bring it down. Bring down the 0. Okay, so now we're going to ask ourselves, how many times does 15 go into 90? Well, we know that 90 is a multiple of 15 because it's right here. And 15 times what is 90? Okay, let's find out. That's 15 times 1, 2, 3, 4, 5, 6. So we know that 15 times 6 is 90. So minus 90. And our remainder is 0. So that means that our answer is exactly 16 wholes. Okay, we have no remainder. Okay, the answer is 16 wholes here.